Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So today again sharing moment. So today is Friday 20 January 2023. So I'm going to talk about supercapacitor, basically asymmetric supercapacitor, from the beginning until the end, what you need to do to make a complete journal or a paper. So it's quite simple. First thing first, you should identify what is your substrate. So normally people can use nickel foam as a substrate. They can use indium tin oxide glass, for example what I have here. So this is the indium tin oxide glasses. Sometimes people will use FTO, fluorine tin oxide, so a lot of substrate. So depend on your availability, you can use either glasses, carbon cloths, or freestanding. So just fix your substrate so you don't have to play around a lot of things. So first thing first, identify your substrate. Okay, second thing is identify your material. So either you want to study about metal oxide or the hot topic nowadays, MXene, or you want to study about carbon-based material, you must know your material. That is the second thing, because different material will have a different criteria. Some might suitable at positive potential, some might possible to the negative potential. So depend on your material. For example, carbon-based material, for example graphene, most likely used as a negative electron, because the readings or the potential can be read at the negative potential. For example, if you have a metal oxide, in my case that I'm studying phosphate based material, so metal oxide combined with phosphate, the reading is at the positive potential. So depend on your material. That's the second thing. So I repeat, first thing, you should fix your substrate. Second thing, understanding or knowing your material behavior. Okay, so then you already have your substrate, you already have your material, you also want to have your electrolyte. So normally, if young researcher always jump to the KOH, potassium hydroxide, because theoretically KOH, potassium hydroxide, give a higher capacitance or higher capacity. But actually you can do a preliminary study by study different type of electrolyte. You can either use KCl, KOH, LiOH. Other than that, you can use sodium sulfate. You can use other lot of aqueous electrolyte, because electrolyte itself is divided into wide range. Either you can use aqueous electrolyte, non-aqueous electrolyte, ionic electrolyte, because nowadays people keep using the ionic electrolyte to get a higher performance. So depend on you. If you want to make the electrolyte as your main study, then fix your material, study the electrolyte. If you want to study the material, then fix the electrolyte. So depends on your study. Okay, so no need to make so complicated. So understanding your substrate, material, and electrolyte. So if you already have all that, so it's set up, you can do the supercapacitor quite easily. Okay, so next, after that, you must know your technique of deposition of your material. For example, if you have a substrate, so how you want to deposit your material on the substrate. For example, ITO, FTO glasses are conductive substrate. So you might going to think how you want to put your material on this small glass substrate. You can either use hydrothermal technique, spin coating, a very easy one, spin coating. You can use deposition technique or microwave technique, or even you can use doctor blading technique or just drop casting technique. A lot of techniques. Just find one. Which one is your novelty? Is it your material or is it your technique? If you want to combine both, also can, but a little bit headache, but it is possible, depend on you. If you are just going to learn about the supercapacitor, just fix one. Either you want to study or optimize the deposition technique, or either you want to optimize the concentration of your material. So let's speed up a little bit. So basically, let me assume you already know your technique. For example, you want to do a direct deposition. For example, you are using cyclic photometry. So then you can optimize the cycle number and also scan rate and also the potential window. A lot of things to optimize. Okay, just imagine you already know your technique, you already have your substrate, electrolyte, and also your material, and you already successfully deposited your sample. Let me show you what is meant by successfully deposited. For example, I already have my sample on this substrate, and this sample already nicely coated on the substrate. So next, I can move on to the characterization. But before I go detail into that, you must understand in supercapacitor. So we are saying about specific capacitance or specific capacity, means that the value is fast fixed. You should either make the areal capacitance, or you can either use the mass to get the specific capacitance. So normally in our lab, we get the mass of the electrode first. So it is very basic. So what you need to do is you just wait the blank ITO without the sample. So wait for initial mass, then after that you wait your ITO with the sample, and you minus, you got the weight of your electrode. And that weight or mass of your electrode is very important, because you need it to calculate the specific capacitance or specific capacity. It's not only for ITO or FTO. Also, if you have carbon cloth or something like other substrates like flexible ITO or so on. So make sure to wait first. If you don't want to use the mass or the weight, you can use the area, fix the area. For example, 1 centimeter square. So you can use the areal capacitance. Okay, that's very important, don't forget that. Okay, then after you do that, you can study the 3 electrode system. So basically, supercapacitor, when you read paper, some paper only report 3 electrode system. Some paper jump to 2 electrode system. Some paper combine the 3 electrode and 2 electrode. So it depends on you actually. Either you want to study 3 electrode only, or just jump to 2 electrode and also study both. So in our lab, we practice to study both the behavior at 3 electrode system and also 2 electrode system, because we focus to produce asymmetric supercapacitor. Means that our positive electrode and negative electrode is different material. So that's why we study 3 electrode system first and 2 electrode system. Okay, after you got your material, so you want to confirm, is it your material is there? For example, you want to deposit cobalt oxide. You want to believe from the cobalt source, it's become the cobalt oxide. So when you want to believe, you should confirm with other characterization. You can go for FTIR to know the functional group. You can go for XRD to know the diffractional peaks or XRD patterns, because each peaks have their fingerprint. You can see the crystallographic for cobalt oxide on the XRD. And you also can go deeper into XPS, because XPS can tell you more about the metal oxide. Is a cobalt 2 plus or cobalt 3 plus? So you can get details from XPS. So these 3, and including Raman spectroscopy, is very important to determine your sample. Is it successfully deposited or not? It doesn't matter which technique you use, but you must confirm first your material is there. It's not other things. If, for example, it's cobalt oxide, it's cobalt oxide. Not suddenly become cobalt sulfate or so on. So focus on confirming your material. Okay, after that, don't go for FISM first, because FISM is quite expensive. Go to some instrument that very cheap. If you go to FISM, then your material is not there, so it's going to waste your money. Okay, after that, move to the analytical part for electrochemical analysis. So we move to 3 electrode system. So what you need to do first is you should study the potential window. You can read from paper, from journal. They say potential window of this certain material, for example, is from 0 to 0.5. But you don't believe 100% is from 0 to 0.5. But you should believe that it is a positive potential. So what you can do, you can take one sample and scan from 0 to positive 1 or positive 2. You want to see the behavior. And you can see that the curve going to start to forming. And if you increase the potential window up to 1 to 2, you can see that a straight line indicating that it's positive. If I'm not mistaken, it's hydrogen evolution. So we want to avoid that. That's why some paper do the pre-skinning but not reported in the paper. That's why the potential window shrinks. For example, for metal oxide from 0 to 0.5 or 0.6 volt. So that's the case why it's happened. Okay, enough with that. For example, you already do the screening at large potential window and you get the potential window range from 0 to 0.5. So fix it. Okay, next, after you know that what you need to do, first thing first, study the cyclic voltammetry at different scan rate you want to see behavior. So you can study, for example, at 5 millivolts per second, 10, 25, 50, 100, 150 and 200 millivolts per second. You want to see the changes on the shape of the CV. If the shape of the CV is remain or unchanged or slightly changed, means that your sample have good rate capability. It can charging, discharge very good. So depends on your material. A lot of pseudo or battery type material, they have lack of capability to maintain the shape. You can see the shifting. Okay, enough with that. So first study CV, cyclic voltammetry at different scan rate. From there, you can see the shifting or not shifting the shape, and you can actually identify the shape. If you study the battery grade material or supercapacitor, you can see a distorted shape. Or if battery grade material, you can actually distinct the redox peaks. You can see the redox peak very clearly. Okay, depend on your material. So this need a lot of study on the channel, a lot regarding the shape and also regarding the shifting or not. So you should study more on the journal on that. Okay, second analysis, study the galvanostatic charge discharge. Okay, normal supercapacitor, if you have EDLC, electrical double layer, you should get a triangle, very good triangle like the pyramid in the Egypt. So if you have pseudocapacitor, the triangle slightly distorted. So it's not very symmetric, slightly distorted. If you study battery grade or supercapacitor, you can see a plate tube on your triangle. So depends on your material. So first, CV different scan rate, second GCD different current density. So at GCD different current density, what you should know, you should focus on different range of current density. Mostly people study above 1 to 10 and so on. For example, you want to do 1 ampere per gram, 2 ampere per gram, 3 ampere per gram until 10 ampere per gram. So a lot of paper focus on higher current density. But if your material cannot achieve, you can go slightly lower 1 ampere per gram. Okay, then again the same for GCD. Observe the shape and observe the IR drop and also observe the discharging time. So it's very important that. So after that, you already finished for 3 electrode system. Just run for electrochemical impedance. For the resistance, you want to do the Nyquist plot to see the resistance of your material. And also you can either study the stability by running the GCD or CV at certain cycle, and then you want to observe the stability of your material. But normally people study the stability on 2 electrode system, not 3, but there are some journals that study the stability on the 3 electrode system. Okay, then if you get a promising result, for example, your target to get 200 farad per gram, 300, so you already achieved, and you got more than that, so means that your sample is good. So you can send for other characterization, for example, FISAM, TEM, to observe the morphology, and you can jump forward to the 2 electrode system. Okay, quite easy, right? After you got that, you can jump to 2 electrode system. And for 2 electrode system, if you have asymmetric, what you need to do, asymmetric supercapacitor, so your material for 3 electrode system is the positive electrode, just need to find one common negative electrode. Normally we are using activated carbon. So it's very easy, just sandwich together, put the separator in between and electrolyte. So what you need to do, just measure the electrochemical performance. You can go for CV at different potential window, CV at different scan rate, GCD at different potential window, GCD at different current density, and you can study the stability, and last but not least, don't forget to measure the specific capacity. Not specific capacity, don't forget, specific capacity is a mass, specific capacitance is a mass, specific capacity or specific capacitance, and don't forget to measure the specific power and also specific energy. Then plot the Raygun plot. Okay, then your study is complete. Okay, I think supercapacitor, if you read a lot of paper, the trend is the same. They are studying the same thing, same measurement, same analysis. What you need to do, make some research, find 5 most notable research, notable journal, and make it as reference, and do your analysis based on that. For example, if they do the electrochemical impedance, EIS, you also need to do the EIS. So it actually should be tally. So a good and enough result will help you to publish in a good journal. So I think there's a little bit elaboration on the supercapacitor, basically asymmetric supercapacitor. I hope you success on your future endeavor. Okay, bye. See you again.